Light, it's everywhere, illuminating our world. But what happens when we zoom in way in to the tiniest parts of light? That's where the incredible field of quantum optics comes into play. This mind-bending branch of science focuses on how light behaves and interacts on a quantum scale. We're going to journey through its basic principles and even explore how it could revolutionize various sectors. So buckle up as we dive into the captivating world of quantum optics. To understand quantum optics, we first need to understand light itself. Light is a bit of a show-off, you see. It loves playing two roles at once. On one hand, it behaves like a wave, spreading out and interfering with itself, much like ripples on a pond. On the other, it acts like a particle, a tiny bit of matter called a photon, zipping through space. It's a bit like an actor playing two characters in the same movie. But here's where it gets even more interesting. Light energy doesn't come in a continuous flow. Instead, it exists in discrete packets, like a box of chocolates, where each piece is a photon. You can't have half a photon, just like you can't have half a chocolate. Well, technically you can, but who wants half a chocolate, right? So, light is both a wave and a particle, and its energy comes in little packets called photons. Fascinating, isn't it? Now that we understand light, let's see how it behaves at the quantum level. What we find is truly extraordinary. Imagine an invisible dance where light photons and matter atoms and molecules interact in the most fascinating ways. Picture a photon zipping through space until it encounters an atom. It gets absorbed, causing the atom to jump to a higher energy level. But this excited state is unstable, so the atom soon releases the photon and falls back to its original state. This dance is the core of quantum optics. Now, let's talk about lasers, a perfect example of quantum optics in action. Lasers are not just for sci-fi movies or barcode scanners. They're based on the principle of stimulated emission. Here's how it works. An excited atom, when hit by a photon of the same energy, doesn't just absorb it. Instead, it releases two identical photons, amplifying the light. And that's how we get a laser beam. Lasers are everywhere around us. They're used in surgeries to make precise cuts, in telecommunications for transmitting data, and even in industries for cutting and shaping materials. Quantum optics has also given us holograms, those 3D images that seem to jump right out at you. They're made by capturing the interference pattern of laser light, yet another marvel of light's quantum behavior. From lasers to holograms, quantum optics is already making its mark in our world. Quantum optics doesn't stop at lasers. It's also paving the way for incredible new technologies. Let's dive into the mind-bending concept of quantum entanglement. Picture this. Two particles, let's say photons, are so deeply linked that a change in one instantaneously affects the other, regardless of the distance separating them. It's like magic, isn't it? But it's not magic, it's quantum physics. This strange phenomenon opens up a whole new world of possibilities. Imagine, for instance, the potential of quantum computers. These aren't just your everyday supercomputers, but machines that can process vast amounts of information at lightning speed, thanks to the magic of quantum mechanics. Or consider quantum cryptography, a secure communication method that's virtually unbreakable. It's all based on the principles of quantum optics. With quantum entanglement and quantum information science, the possibilities are endless. So, where is all this quantum optics taking us? Well, imagine a future with advanced materials, ultra-precise sensors, and revolutionary communication systems. That's the potential power of quantum optics. But of course, the quantum realm is a complex one, filled with mysteries that scientists are still trying to unravel. Despite these challenges, ongoing research is bursting with promise, opening up endless possibilities. Quantum optics is not just about understanding light, it's about unlocking the limitless potential of the quantum world. Quantum optics. It's a fascinating field, isn't it? We've journeyed together through the world of light, from its wave-particle duality to quantum entanglement. We've seen how lasers work and explored the potential of quantum information science. The future is bright with possibilities from advanced materials to revolutionary communication systems. But remember, this intricate world of quantum optics doesn't lie far in the future. It's right here, right now in the light around us. So remember, next time you turn on a light, you're not just lighting up a room, you're sparking a quantum revolution.